Today's class will bring kinetic friction also into the picture. So let's say this is a block of mass, suppose 5 kg, and the coefficient of static friction between the block and the ground is 0.4. Okay. Tell me, what is the minimum horizontal force required to slide this block? Minimum horizontal force required to slide this block. Calculate quickly. Okay, I got one answer as 20 newtons, right? One more also has 20. Fine, 20 newtons is correct. Okay. First, you need to consider what all forces act on the block. Its weight 50 Newton will be acting. Because we are only applying the force horizontally, the normal force on the block will have to balance the weight completely. So normal force here will be 50 Newtons. And if normal force is 50 Newtons, limiting friction, that is mu s into n, becomes 0.4 into 50, that is 20 Newtons. Okay. So friction can increase itself up to 20 Newtons to prevent the block from sliding. Then the force you apply should be greater than 20 in order to start sliding the block. Okay. Answer this quickly, unmute and tell the answer. Suppose we apply a force of only 15 Newton. How much friction acts on the block? Suppose you apply only 15 Newton, how much frictional force acts on the block?
15 Newton.
15 Newtons itself. Okay. Because friction will try its best to prevent sliding, and to prevent sliding in this case, 15 Newton is sufficient. So only 15 Newton friction will act. Okay, correct. Now, suppose you apply a force of 30 Newton on this block. Now tell me, can the block stay at rest?
No, sir.
Definitely not, because the limiting friction is only 20 Newton. Friction cannot exceed that value, but you are applying 30 Newton. Then what will happen? The block will start sliding. Okay. Once an object starts sliding on a surface, what kind of friction acts on it? Is it still static friction, or is it kinetic friction, or do you think both will act?
Kinetic friction, sir.
Okay. Others, what do you think? Once the object starts sliding, what kind of friction acts on the object? It will be kinetic frictions. If do you all think friction will be acting when an object is sliding or not? Will there be some opposition to sliding or not?
Yes, sir. There will be some opposition to sliding.
There will be, okay. And that opposing force while sliding is what we call kinetic friction. So when you apply a force of 30 Newton, this 30 Newton is more than limiting friction. Therefore, the object slides forward in the direction of that sliding force. And naturally, if the surfaces are rough, there will be friction acting backward. And the friction acting now is called kinetic friction. Okay. Now, see, sliding has started. Now, if sliding has started, friction will obviously put its maximum effort to prevent sliding. No, why will it put lesser effort? Friction will try its best to prevent sliding. So for kinetic friction, you can directly use this formula mu k multiplied with n, where mu k is called the coefficient of kinetic friction. Okay, so kinetic friction also depends on the nature of surfaces, the roughness of surfaces, and normal force between the surfaces. Okay, so static friction, kinetic friction, the factors on which they depend is the same. Fine. But here we have used the symbol mu k because coefficient of static friction is usually different from coefficient of kinetic friction between two surfaces. Okay, it has been determined experimentally. Fine. So now listen, suppose the coefficient of kinetic friction in this case is 0.2. Quickly tell me, how much will the friction acting be? Coefficient of kinetic friction is 0.2. You can see the normal force and all. So how much friction will be acting on the block now? Okay, Rishi, your answer is correct only. Right. 10 Newton friction will be acting. 0.2 multiplied with the normal force of 50 Newton. That will be 10 Newton. Okay. We are dragging it with a force of 30 Newton. Friction acting is 10 Newton, kinetic friction. Then tell me, how much is the net force on the block? Saket?
So 30 minus 10, 20.
30 minus 10, that becomes 20 Newton. You can equate it to its mass multiplied with acceleration. You can even tell the acceleration of the block, that will be 4 meters per second square. So we are just looking at how to consider kinetic friction in an equation, okay, or in a situation. So if static friction is not sufficient to prevent sliding, the object will start sliding. Or you may be given situations where the object is already sliding. You don't have to decide whether it starts or not. Okay, it may already be sliding. In such cases, you need to consider kinetic friction if the surfaces are rough. And this is the formula for kinetic friction, mu k multiplied with n. Can one of you quickly tell me in which direction, not in this particular question, generally, in which direction does kinetic friction act? In which direction does kinetic friction act? Okay, in this case, we know that kinetic friction is acting to the left. Why is it acting to the left? Why not in some other direction?
Sir, because it's being pulled towards the right.
Ha, you should say because it is sliding to the right. Fine. Basically, friction tries to prevent sliding. No, if an object has already started sliding, then friction acts exactly opposite to the direction in which the object is sliding. What other choice does it have? Okay, so kinetic friction acts opposite to the direction in which the object is sliding. Okay, let's solve problems based on this. Consider this situation itself. Surface is rough. It has a coefficient of kinetic friction, let's say 0. Let's take 0.4. Assume mass of the block is some 2 kg. And we have given it an initial velocity of, let's say, 10 meters per second and released it. Okay, now in an everyday situation, you imagine, suppose you push a notebook along a surface, you give it some speed and then you leave it. What will happen to it naturally? If we give some velocity to an object and slide it and release, what is going to happen to it? Vanilla, what will happen?
It will move some distance and then stop moving.
Huh. So it will move forward for some distance. It will slide for some distance and then stop. While sliding, what will happen to its velocity? As it slides forward, what happens to its velocity?
Decrease.
It decreases. No, it gradually decreases, and at some point it will become 0. Correct. What force is responsible for this decrease in velocity?
Friction, sir.
Friction itself. What else can prevent sliding? Okay, in this case we are not applying any force. We have given it some velocity and released. Okay, so after that the forces acting will be weight, normal force, and the friction acting on the block. Okay, so tell me, what all shall we calculate? Pawan, tell some questions based on this situation.
Sir, friction.
Okay, calculate the friction acting on the block, and then what can be calculated based on that?
Sir, we can calculate normal force.
For friction, you will have to calculate normal anyway. Okay, after that, anything about the motion of the block? Okay, acceleration. With acceleration, you can find out how far it will move before stopping. Okay, so distance moved before stopping. Okay, try these all of you. The block is given an initial velocity of 10 meters per second parallel to the surface and released. Okay. So as I said, whenever you are asked to find out what happens to a system, first consider the forces acting on it. Its weight will be acting this way. There will be a normal force acting on it. You can tell how much it is. And because it is sliding, there will be friction acting on it. And because it is sliding, we call it kinetic friction. Okay. Solve all three parts quickly, all of you. Okay. Yusuf, have you calculated the friction? Okay. Saket, how much is the friction acting on the block?
Sir, 8 Newton.
Okay. The formula?
No. Coefficient of kinetic friction into normal force.
Normal force. 0.4 into how much will the normal force here be?
20 newtons.
20 itself, because see, from everyday experience, we can tell an object which is sliding on the surface will slide on the surface only. It won't jump off the surface. No. So vertically, the block is in equilibrium. Horizontally, it may be slowing down, but vertically, nothing is happening to it. Okay, it doesn't have a vertical velocity. It doesn't gain any vertical velocity also. Means net force in the vertical direction is 0. That way we can tell that the normal force is 20 Newton. So 0.4 into 20, the friction acting is 8 Newtons. Correct. Okay. Pawan, how much will the acceleration of the block be?
Sir, 1 meter per second, sir.
Why will it be 1?
Sir, ఇప్పుడు మనకి ఫ్రిక్షన్ 8 న్యూటన్స్ సార్. ఇంకా
Friction is 8
ఆపోజిట్ లో 10.
Newton. That 10 is not a force. Okay, so tell me how much will the acceleration be?
Sir, 4 meter per second, sir.
In which direction will that acceleration be?
Sir, backward.
So listen, you are given a situation and you are asked what is the acceleration of the object. Acceleration can be calculated as net force divided by mass. Okay. Now in this situation, normal force and 20 Newton weight are balanced. They'll get cancelled. The only unbalanced force is friction. That itself will be the net force on this block. So net force will be 8 newtons divided by mass of 2 kg. The acceleration is 4 meter per second square backward. So you can write it as minus I cap, or you can write minus 4 meters per second square. Okay, I cap. Friction also, if you want, you can assign a direction to it, minus 8 Newton I cap. Okay. Now the last part of the question. Rishi, can you tell me any idea how to calculate the distance it moves before stopping?
So use the 10 meter per second and the 4 meter per second and then just calculate.
Which equation will you use to calculate? Okay.
Sir, I'm not sure.
Fine. Vanilla, can you tell how to calculate the final velocity, not final velocity, the stopping distance of this block?
V square minus U square equal to 2AS, sir.
Favorite equation. Okay. How do you justify that? Okay, you tell me, when are equations of kinematics applicable?
When acceleration is constant.
Acceleration is constant. We need to ensure that first. Now see, the surface on which the block is sliding is horizontal. Okay. Since the surface is horizontal, normal force will always be 20 newtons. If normal force is always 20, friction will always be minus 8, acceleration will always be minus 4 as long as it slides. Okay. So we can say that this acceleration is going to remain constant, and we can use equations of kinematics to find out the stopping distance. Now when it stops, what is the final velocity of the block?
0, sir.
Initial velocity is 10 meter per second, final velocity becomes 0. That distance is what we need to calculate. Okay, as you said, v square minus u square is equal to 2as can be used. V square minus u square is 2. Acceleration must be taken minus 4, otherwise you will get this answer wrong. Okay, s. So you get minus 100 is equal to minus 8s. Minuses cancel. 100 equal to 8s. So the distance, actually the displacement covered before stopping will be 100 by 8, that is 12.5 meters. And because it moves in a straight line without changing direction, displacement will be equal to distance. Okay, so it moves or it slides for 12.5 meters before stopping. Okay, just think about the steps, all of you. And see, in exams, how they will ask you, they'll ask you this question directly. How much distance it moves before stopping? You will have to think on what factor. First, you'll have to think, why will the block stop? What force is making it stop? Friction. You'll have to calculate friction. And to calculate distance, you need to know something about velocities. You need to know something about accelerations. So from friction, you find out acceleration. Then if it's constant, use equations of kinematics, get the distance. Okay, those steps you'll have to think on your own. That's the difference between solving in class and solving in the exam. So you will need to practice a lot to be able to comfortably solve such questions. Is this clear to all of you? Any doubts in this? Okay. Now consider this situation. Let's say this is a 5 kg block, rough surface, coefficient of kinetic friction is suppose 0.2. I want you to find out what speed the block must initially be given, okay, such that it slides 10 meters before stopping. Try this, all of you. Okay, I got one answer as square root of 40. We'll see. Pawan, how are you trying to solve this question?
The same answer.
Okay. Saket, you gave some answer for which question is that?
Sir, I followed the previous format only. So like friction, and then I gave the answer for acceleration, then I gave answer for U.
Okay, 2 root 10, that is root 40 itself. Okay, fine. So all of you seem to be getting the same answer. Rishi, what about you? How are you trying to solve this?
Third, the same approach as the last one.
Okay, fine, fine. So you need the initial speed such that it slides 10 meters and stops. So we know the displacement. We know the final velocity is 0. Okay, and we need initial velocity. The only thing missing is the acceleration. Acceleration can be calculated from friction. We know weight and normal force act vertically. The only horizontal force acting on this block is friction. That itself will be the net force. Okay, correct. So net force mu k into n 0.2 into 50. That becomes 10 newtons. And the acceleration because of friction, or the acceleration of the block, net force divided by the mass, 2 meters per second square. It will be towards left, so you should take it as -2. That's all. Now you know all the required information. Substitute in v square minus u square is 2as. You get the initial speed. Okay. I guess root 40 is correct. Let it be. Now consider this situation. See, usually in questions, we ignore the dimensions of the blocks. Okay. Unless they particularly specify, you will consider the block to be a small object only. So let's say there's a situation like this. Assume the angle of incline is 37 degrees. Block's mass, let's take it as 2 kg. And between the block and the surface, the coefficient of static friction is 0. Let's say 5, and the coefficient of kinetic friction is 0.4. We didn't talk about this, but usually the coefficient of static friction and coefficient of kinetic friction will be slightly different. And generally the kinetic friction coefficient will be smaller than the static. We'll talk about this. Okay. So yeah, this block is released from rest. And let's say the length of the inclined surface, that slant length is, okay, let's take 10 meters. So first thing, will the block slide? If it does, okay, wait, will the block slide? If yes, calculate the time taken. Time, no, let's, you can calculate time also. Calculate the time taken to reach the bottom. Bottom of the incline, that is. If you think it does not slide, calculate the friction. No. If you think it does not slide, calculate the minimum angle at which it starts sliding. Okay, solve this carefully, all of you. So will the block slide or not?
Yes, sir.
Yes, sir.
Okay. How did you check that?
Sir, static friction and force down the incline.
Okay, you compared limiting friction and the force pulling it down the incline. Fine. An easier way would be to just compare mu s and tan theta. Okay, like that angle of repose idea. One of you quickly tell me how much is tan 37 degrees?
3/4, sir.
3 by 4. That is 0.75. Now this is clearly greater than the coefficient of static friction. So it means tan theta is too much. It means theta is too much. Okay, it means the angle is more than the angle of repose. So the block slides. Okay, and once it starts sliding, you will not consider static friction anymore. The only friction acting on it will be kinetic friction. Okay, solve it quickly. Okay, I got one answer for time as root 5 seconds. One answer as root 10. Pawan, can you tell how you are trying to solve calculate the time taken to reach the bottom?
Sir, S is equal to UT plus half AT square.
You want to use S is equal to UT plus half AT square. We know the initial velocity. We know the displacement. Okay, you need to calculate acceleration. Time. If you know the acceleration, you can tell the time taken to reach the bottom of the incline. Okay, correct. We don't know the final velocity, so we can't use V is equal to U plus AT. Okay, Pawan, tell me what forces act on the block?
Sir, normal and mg sin theta.
Normal and mg sin theta. Why are you so particular about normal? Why not the other forces? What will happen to mg cos theta?
Sir, normal అంటే mg cos equal వస్తాయి కదా.
Normal is not the same as mg cos theta. Magnitude wise they are same, but they are two separate forces. Normal చెప్పి mg cos theta చెప్పడం మానేస్తాయింది. No, it's not like that. Okay, normal arises because of mg cos theta only. So చెప్తే first mg cos theta నే చెప్పాలి. So there will be one force acting this way, mg cos theta. How much is it? Magnitude, numerical value shape. 20 cos 37.
Sir, 16 newtons.
16. mg sin theta.
12 newtons.
12. Normal force.
16 newtons.
Normal force has to balance mg cos theta. Okay, so 16 newtons. And
Frictional force.
friction will be acting on it. This block was released from rest due to the mg sin theta component, 12 newtons, pulling it down the incline. It starts sliding down. Then we can say that friction will act up the incline. Okay. What kind of friction?
Kinetic friction.
Kinetic friction. How much?
6.4.
Okay. Kinetic friction is mu k into n. Mu k is 0.4. Normal force is 16. 16 into 0.16 force is 64. 0 point will be 6.4 Newton. That's the kinetic friction acting on the block. Okay. Now tell me what is the net force acting on it, Pawan, and in which direction it is.
Sir, downwards.
Downward center, down the incline and Japali. Okay. How much?
5.6. Sir.
Okay. 12 minus 6.4. 5.6 Newton is the net force acting on the block. From that, you get the acceleration. And see, the angle of incline never changes. If angle of inclination doesn't change, mg cos theta will not change. If theta is same everywhere, then you can be sure that mg cos theta is same everywhere. And if that is same everywhere, normal force will be same everywhere. Then from that, you can say friction will be same everywhere. Then you can say it will move with a constant acceleration. That check you have to do. Okay. So net force is 5.6 Newton. So net force is equal to mass into acceleration. You get an acceleration of 5.6 by 2, 2.8 meters per second square. With that, you can tell the time it takes to reach the bottom of the incline. S is equal to ut plus half at square. Displacement, acceleration are in the same direction. Let us take both of them positive. U is 0. A is 2.8 t square. So 2.8 by 2 is 1.4. T square is equal to 10 by 1.4. Or 100 by 14, 50 by 7. T will be under root 50 by 7. Vanilla, what mistake did you make?
did calculation mistakes.
They were.
అంటే లిమిటింగ్ ఫ్రిక్షన్ తోనే క్యాలిక్యులేట్ చేసినందుకు అంత వచ్చింది.
Okay. Limiting friction is only to check whether the block's sliding will be prevented or not. And here limiting friction is not sufficient to prevent sliding. So sliding will occur. Once sliding occurs, you forget about static friction. You need to consider only kinetic friction. Saket, what mistake did you make?
Sir, I took normal force as 20. Sir.
On incline, it is not like that. In fact, on horizontal surface also, it won't always be mg. We'll deal with situations like that. Okay. Let's try another question. Okay, suppose this block is projected up with a speed of, let's say, some 10 meters per second. So since it is projected, definitely it will slide. Assume coefficient of kinetic friction between the block and the surface is 0.5 and coefficient of static friction is 0.9. Okay, usually these values will be less than 1 only. Okay, you know the initial speed and all. Fine. So first question. How far up the incline does the block slide? Start solving. This time mass of the block is intentionally not given. If required, you assume it is m. If it's not given in the problem, it means it does not matter. So if you want, you take it as m. You will see that it gets cancelled somewhere. Angle needs to be given. Just a moment. Angle 37 degrees itself you take. Cos 37 degrees is 4 by 5. Sin 37 degrees is 3 by 5. Use them. Okay, I got one answer as 100 by 8 to the first part, another answer as 25 meters. Let's see. Rishi, how are you trying to solve this?
I'm not sure.
The question, see, in physics, not just in this question, generally when you are given any problem in physics, you should first think of why. Okay, I mean, what happens to the system? The question is asking you how far up the incline does the block slide. So you need to think, why should there be a limit to the distance it slides? Tell me, what prevents the block from going up?
Friction.
Okay, anyone else? What prevents the block from going up? There is chance that most of you make the mistake in the first step itself. I want answers. What prevents the block from going up the incline?
Sir, the slope.
Gravity, sir.
Is it only gravity, only friction, or both? It's actually both. Okay, and if you haven't considered both, then you will not get the correct answer. The initial velocity is 10 meters per second. Let it be. Visualize the forces acting on the block. There will be an mg sine theta acting down the incline like this. M is not given. Leave it. Doesn't matter. I'll just mention it. Mg sine theta. There will be an mg cos theta acting like this. There will be a normal force acting. And because this block has been given a velocity up the incline, there will be friction also acting this way, down the incline. Friction opposes sliding. Okay, friction has no enmity with anything else. Friction doesn't have to oppose mg sine theta. Friction doesn't have to oppose any force. Friction has to oppose sliding. This block is sliding up the incline, so friction will act down the incline. And what kind of friction? Kinetic friction. As long as it slides, it is kinetic friction. Okay, somewhere when it stops, it becomes static friction. That situation we'll discuss later. So normal force balances mg cos theta. Okay, but both these forces, mg sine theta and kinetic friction, are unbalanced. They are both in the same direction, so they'll add up. Okay, they become the unbalanced forces on this system. So now you can say that the net force acting on the block is mg sine theta plus kinetic friction. Kinetic friction is mu k into normal force. Normal force is mg cos theta. And equating this to mass into acceleration, you get the acceleration. And this is why I said mass does not matter. It will get cancelled. Therefore, the acceleration of this block becomes g sine theta plus mu k g cos theta. Substitute the values. G is 10. We can take it common. Sine theta, sine 37 is 3 by 5 plus mu k is given 0.5, that is 1 by 2. Cos theta is 4 by 5. Now 1 by 2 into 4 by 5 is 2 by 5. 3 by 5 plus 2 by 5 becomes 5 by 5, that is 1. Okay, so the acceleration here is 10 meters per second square. We'll take a minus sign because it is opposite to the initial velocity. Okay, with that you can tell how far it slides up the incline. Which equation will you use to find out how far it slides once you know the acceleration? The block will come to rest somewhere here, and throughout the journey, the acceleration would be constant because theta is the same everywhere. The acceleration will be constant. So you can use equations of kinematics to get the distance that it slides. So v square minus u square is 2as. Minus s cancel. 10 by 2. It slides 5 meters before stopping. Okay. See, the first thing you need to do, whether they tell you to do it or not in the question, is to consider all forces acting on the block with proper directions. Okay, just think about this once again, all of you. Ask if you have any questions. Mg sin theta plus friction together becomes the net force on this block. Okay. Now see, most of you are attending school or classes separately also, but tell me, for how many of you friction has been taught already? Rishi, I understand. Saket, which chapter are they teaching you in school now?
Sir, they just started NLMC.
Started laws of motion. Okay.
Yes.
Okay, fine. Pawan, what about you?
Sir, work for energy.
That means this chapter is complete. So practice a little more. Okay, without these basics, jumping to the next chapter is not suggested. If you want, I'll give you questions, or I think you have those books also. Solve more questions from them. Vanilla, what chapter are they teaching you?
Newton's laws of motion, sir.
Okay, friction part has started or not?
No, sir.
Not yet. Okay. Yusuf, what about you? What are they teaching at school?
So work for energy.
And then you also, you need to practice more laws of motion more. Okay. These three laws of motion, next chapter work energy power, and the chapter of that after that rotational motion, or some call it system of particles. These are the most important chapters of your entire syllabus. Okay. Why are they why are they the most important? Because these ideas will be used in all the chapters that follow, even in your 12th class, except in some chapters like wave optics, ray optics. Okay. In all other chapters, these ideas will be used. So these are chapters where you learn some fundamental ideas in physics. So spend more time on these, practice more problems from these chapters. In your final exam, you will get only one question from each chapter, maybe two questions at the most. But that doesn't mean you leave out these chapters, or you cannot neglect these chapters. Okay. As I said, these chapters have the fundamentals which will be used in all the chapters that follow. Fine. Okay, now, okay, second part of the question we didn't discuss. No? Tell me, we know after sliding 5 meters, it stops. That's fine. Yusuf, what do you think happens after that, after it stops?
So if it comes back down slowly.
Okay. Saket also is saying it will start coming down the incline, sliding down the incline. Pawan, what do you think?
Sir, it will stay there.
It will?
No, sir, it will come down.
How did you decide it will come down?
Sir, friction ఇంకా ఎంజీ సెందిట ఒకే ఎక్కువ యాక్ట్ అవుతున్నాయి కాబట్టి.
Okay. See, that is what is interesting here. Listen, assume the block has reached the top. Just a moment. I'll modify the diagram. Vanilla, what do you say? What happens after it covers that 5 meters?
It won't slide down, sir.
Why? Will friction and mg sin theta not pull it down?
Sir, friction అంటే పైకి వెళ్ళాక ఆపోజిట్ డైరెక్షన్ యాక్ట్ అవుతుంది కదా సార్.
Good, good. See, once the velocity becomes 0, mg sin theta continues to act on the block. Now see, friction, why it acts is to prevent sliding. Okay. Initially, because of the velocity that we have given, that how much velocity had we given? 10 meters per second up the incline. Because of that, the block was already sliding up. So friction had to act in the downward direction. Friction had no other choice. But when the object stops sliding, friction now has a choice. If it's not necessary, it need not act. If the block starts moving in any other direction, then it will act opposite to that direction. Okay, so friction can change its direction as necessary. It will change, why not? Once the block stops, the block then has a tendency to slide down the incline. The velocity that we have given is gone. So because of mg sin theta, it now tends to slide down the incline. Then the moment it stops, friction will start acting up the incline. Okay. Why will friction keep acting downward? Indirectly, you are saying friction will bring the block down. That is meaningless. Friction prevents sliding. Okay, tries to prevent sliding. Okay, so now we have to check whether it starts sliding down or not. So it's like once it covers that 5-meter distance, it becomes a new problem. It's like the block is released from rest now. And one of you quickly tell me, how do you check if the block can slide down or not?
Tan theta is less than mu s, sir.
You have to compare tan theta and mu s values. Theta is 37 degrees, tan 37 is 0.75. Mu s given in the problem is 0.9. Okay. So since mu s is 0.9, quite high, static friction will be sufficient to prevent sliding. See, once it stops, static friction will come into play. Okay. And we see that maximum static friction will be more than the value of mg sine theta because mu s is more than tan theta. Therefore, the block will not slide down after it reaches that maximum distance. Okay, so some everyday knowledge also you'll need to apply. If the block is coming down, why will the friction act downwards? It should act upwards. Fine. Okay, just a moment. You all think about this situation. I'll take the diagram for another question. Okay, now consider this situation. There's a block and it's a rough surface, okay? And on top of this block, let us place another object. Okay, some other block is placed on top of this one. So one block on top of another block, right? Let's first assume this surface is smooth and these two surfaces are also perfectly smooth. System is placed like this. Now tell me, if you apply a force, horizontal force on the upper block, what will happen? Initially, both objects were at rest. Okay. So if we start applying a horizontal force on the upper block, what will happen? Yeah. Why is it so hard to answer? Yusuf, what do you think? Response.
Can you repeat the question?
The system was at rest, all surfaces are smooth. What happens if we apply a horizontal force on the upper block?
Sir, the upper block will move.
Okay. What about the lower one? Will it stay there itself?
Yes, sir.
Okay. Vanilla, what do you think?
A block will move towards the right, sir, and B block will stay there only.
A moves to the right, B stays there itself. Okay, fine. So, one of you tell me, what all forces act on A?
Gravitational force, normal, and friction, sir.
Weight, normal, and friction will be acting. Weight acts vertically downwards, normal force upwards. Wait, what did he say? Weight, normal, and?
Force, sir.
Okay, the
That
force that
F.
we are applying. Correct. So, weight and normal force will balance, but this F will be unbalanced. So that becomes a net force acting on it. So it will start accelerating to the right. Correct. Saket, tell me what forces act on the block B?
So weight and normal force.
Weight and normal force only. And they'll both be acting vertically. We know that. So since the forces are vertical, okay. Normal force from where? On B.
Ground on block, sir.
Okay, from ground on block will act this way. Is that all? Will A not be pressing B? What do you think?
Yes, sir. Normal force of A will
It
be
will
on.
be. There will be a normal force from A also. In fact, on A, this normal force is exerted by B. Okay, on A, that normal force is exerted by B. A is not in contact with the ground. So ground won't exert a force on A, but B will exert a force on A. The reaction to that will be exerted by A on B in the downward direction. So B will experience a normal force also downwards by A, and there will be another normal force exerted by the ground. Okay, you can call them N1, N2 if you want. Okay, right. So B only experiences vertical forces, and vertically it won't move. We know that. Horizontally, there is nothing to move B at all. Okay, so it won't move. So A will start accelerating to the right. A will slide off, B stays there itself because there is no horizontal force trying to move B. Is this clear to all of you? Any questions in this? Okay. Suppose the floor is smooth itself, but the surface between the two blocks is rough. Okay. And initially system was at rest. You start pulling the lower block with some force. Okay. Use your imagination, all of you, and tell me what will or could happen to this system.
Block A and B will move towards the right.
Both will move towards the right, you are saying. Okay. Any other answers? I got one answer as both the blocks move when we pull B. Okay. Pawan, what do you think?
Sir, same, sir.
Fine. How are you sure? Why will A move? We are not exerting a horizontal force on A.
Surface between A and B is rough.
Okay. Just because it is rough doesn't mean it has to move. Okay, fine. So you all are convinced that both of them will move. Will they move together?
Yes, sir.
Okay. I want you all to try this. Keep one book on the table. On top of that book, you keep another book or a mobile phone or whatever it is. Okay, just arrange two objects one on top of another and you slide the lower object. I mean, you pull the lower object. Observe and tell me what happens. I'll give you 2 minutes. On a table, you put two objects one on top of another, pull the lower object and tell me what happens. Pawan, what did you observe? Or anyone? What did you observe?
Sir, when both the objects are being pulled like that, it's not like one is not moving and the other is moving. Both of them
Okay.
are being pulled.
Are they moving together?
Yes, sir.
Okay. What objects did you
Sir.
use?
Sir, book and phone.
Okay, fine. Rishi, try this now. Pull the book with a large amount of force, like suddenly. Then tell me if the book and the phone move together. Pawan, you wanted to say something?
Sir, అదే సార్ హ్యూజ్ అమౌంట్ ఆఫ్ ఫోర్స్ పెడుతుంటే పైన ఆబ్జెక్ట్ ఉండట్లేదని చెప్దాం అనుకున్నాను.
Fine object?
అంటే స్టేబుల్ ఉండట్లేదు సార్, అంటే బ్యాక్వర్డ్ వెళ్ళిపోతుంది.
Okay. Okay. So they are not moving together when you pull the lower object with a large amount of force.
Yes, sir. The same thing happens when I.
Okay. So from everyday experience, we can tell that when we apply a force on the lower block, if we pull the lower block gently, you will see both of them moving forward together without sliding over each other. Okay, on the ground they will slide because that floor we are assuming is smooth. So on that they will slide, but between A and B there won't be any sliding if you pull B gently. But if you pull B with a large amount of force, okay, then B will move faster than A. Both of them will move, but you will see B sliding more than A. Okay, so let us discuss what happens in this case actually. See, suppose the force with which you are pulling is a small amount of force. Tell me, apart from this force, what other forces act on B? Anyone? What other
Weight and
forces?
normals.
Weight will be acting, two normals will be acting. Okay, on the block B. These forces we have already considered. weight and two normal forces will be acting. Now, if you pull it to the side with a small amount of force, then in the absence of friction, means had this also been a smooth surface, the block B would have slid to the right. A would have stayed there itself. Okay, anyway, we'll discuss about A separately. B would have moved to the right. And because the force with which you are pulling is small, it would have gotten a small acceleration that way. Now tell me, in this case, what will happen to A? Will it stay there itself or will it slide? Had it been a smooth surface? Think carefully and answer. Had this been a smooth surface, what would have happened to A?
So when block B is moved, A will fall down.
Okay, but till then A will stay there itself or will A slide a little bit?
It won't slide.
It won't slide because there is no friction. The only forces acting on A are its weight and normal force. There is nothing acting on it horizontally. Okay, so even if B goes forward, let us visualize that. Okay, wait, B is stuck to this thing. Never mind. Even if B goes forward, A stays there itself. Just a moment. Situation will be like this. Suppose B moves forward a little bit. It'll be like this. Yeah. A stays at its original place. Even when B slides forward, that is what is going to happen. But when B slides forward too much, then A will fall down due to gravity. Okay, again, there we'll have to discuss the concept of center of gravity and all. But this is what is going to happen roughly. Okay, so in the absence of friction, sliding will definitely happen. The block B slides forward. And relatively, the block A slides backwards. It's actually not moving at all, but with respect to B, it will appear as if A has gone backward. So we say it has slid backward or it slides backward. Okay. Now tell me, in the presence of friction, what will happen? Had it been a rough surface? Let me copy the diagram. The surface between A and B, had it been rough, we have visualized what would have happened if the surface is smooth. Okay. And the purpose we do that is, once you visualize the situation when the surfaces are smooth, you can visualize the direction of sliding. And from that, you can tell the direction in which friction is going to act. Okay. So now tell me what is going to happen. Will friction act between the blocks or not? If the surface between them is rough. Pawan, what do you say? Does friction need to act or not?
Sir, between A and B.
Between A and B.
No, sir.
What does friction do in any situation?
The stable అంటే ఆబ్జెక్ట్ ని కదలకోకుండా అక్కడ ఉంచడం.
సరే చెప్పు.
సార్ అపోజింగ్ ఫోర్స్ ని అంటే ఆపుతా సార్.
నో, ఫ్రిక్షన్కి ఏం పని వేరే ఫోర్సులతో? వాట్ డస్ ఫ్రిక్షన్ డూ ఇన్ ఎనీ సిచ్యువేషన్, ఆర్ వాట్ డస్ ఫ్రిక్షన్ ట్రై టు డూ ఇన్ ఎనీ సిచ్యువేషన్? ఎనీవన్?
It opposes sliding, sir.
If sliding is happening or it tends to happen, friction has to oppose it. That's all. Okay, Pawan, friction opposes sliding. Now we have visualized the situation in the absence of friction. Pawan, tell me, in the absence of friction, sliding is happening or not? Are the
Yes, sir.
blocks, what did you say?
బ్లాక్ ది స్లైడ్ అవుతుంది.
In the absence of friction, are the blocks sliding over each other or not? ఒకదాని మీద ఒకటి స్లైడ్ అవుతున్నాయి లేదా ఫ్రిక్షన్ లేనప్పుడు? They are sliding, right? So now you tell me, does friction need to act or not?
ఎస్ సార్.
Yes. Okay. In any question which involves friction, I'm telling this to all of you, any question which involves friction or rough surfaces, imagine what would happen if the surfaces were smooth. That will help you visualize whether sliding happens or not. And if sliding happens, friction will definitely act when the surfaces are rough. Okay. Vanilla, tell me, in which direction should friction act on the block B?
Towards right, sir.
Towards right. So this way. Chodam. Then if friction acts on block B towards right, then on block A it should act towards left. Action, reaction. Yes or no?
Sir, on block A, friction act towards right, sir.
Okay. And on B?
Towards left.
Towards left. Correct. Okay. See, friction acts such that it prevents sliding. Now we know block B is a lower block. B is sliding forward. So on B, friction will be acting backward like this. And A relatively, okay, A tends to slide backward. So to prevent that relative sliding, friction on A will act forward like this. Is this clear to all of you? Think about this once again and ask me if you have any questions. Okay, hope this is fine. So this friction that acts on A and B tries to make them move together. Friction will always try its best to make the surfaces go together. Okay. Now when the force with which you are pulling is small, you will only be generating a small acceleration. Okay. Which object is the force being applied on? Force is being applied on B. So B will get an acceleration due to this force. But friction does not like sliding. So what friction tries to do is, it will try to make A go along with B. Okay. In fact, it does two things. B is going off, no? It slows down B, that you can tell from this friction acting backward on B. So friction tries to slow down B, and on A, what it is doing, it is pushing A forward and trying, or it's like telling A to go along with B. You go together, don't slide on each other. That is what friction is telling. Okay, and friction will put its best efforts to do that. What friction? Static friction will make its best effort to do that. Okay, so I'm sure you all must have observed, when you pull the lower object slowly, gently, the upper object will move along with the lower object. Okay, so both of them go together. Because of friction only they go together, and the friction acting in that case is static friction. The surfaces, like in this case I can say, just a moment. So I'm also using book and a mobile phone placed on top of it. I'm sure you're able to, okay. I hope you're able to see both of them. Now, I will only move the book, but the mobile phone moves along with it. and there is no sliding between them. So when I move the book this way, the book has a tendency to slide forward. So on the book, the friction will act backward. On the phone, the friction will act forward, and both of them go together like this. You can see relatively there is no sliding between them. The phone on the book is not going forward or backward. It is going along with the book. Due to friction only, they are able to move together. And since they are moving together, there's no relative sliding between the surfaces. The kind of friction acting there is static friction. Okay, just because objects are moving, don't say friction is kinetic. Okay, is there sliding between the objects? That is what you have to see. There is no sliding. Friction is able to make them go together. That kind of friction is called static friction. Okay, now if I pull the book to the side with a lot of force, okay, we'll discuss that case next. Let us work on this first. Right. So when you pull the lower object gently, the small amount of force, friction acts like this and it makes them go together. What friction is it? Static friction. Now we know static friction has limits. When you start increasing this force, basically what you are doing is you are increasing the acceleration of the system. You are trying to make B move faster, B accelerate faster. Okay. B can accelerate because you are applying a force on it. But if B accelerates, there will be sliding between A and B, and friction does not like that. So friction will try to slow down B and speed up A. It will say you both go together. Okay, it's like it pulls B backwards, it pushes A forwards at the same time, trying to make them go together. But as I said, friction has limits. Suppose you apply too much force. Okay, suppose you apply a large amount of force. Then what will happen? B gets too much acceleration, and because friction has limits, suppose its limit is also not sufficient, then what friction does is, like, it will still try its best. It will still be acting on A and B this way, but it won't be able to prevent sliding. Then what will happen? B will go forward, A will. Okay, let us visualize that situation separately. B will go forward, A will also go forward, but not as fast as B. So just a moment, I'll copy the diagram. So under the influence of a small force, friction will be sufficient to prevent sliding. And the blocks move together. Next, if the force is too much, then what will happen? See, these were their original positions. Originally, the left edge of A was here, the left edge of B was here. Okay, so when you apply too much force, what will happen? Both will move forward. So situation is going to be okay. I can use this diagram itself. Just a moment. Surface stays where it was. B moves forward. A also moves forward because there is friction acting on A, but it won't move with the same acceleration as B. This is what is going to happen if you pull the blocks, or if you pull the lower block with too much force. Okay, on the lower block, the friction is still acting backward, On the upper block, the friction is still acting forward. That is why the upper block moves forward in the first place. But friction won't be able to keep them moving together. They'll move separately with their own individual accelerations. And in that case, the friction acting will be kinetic in nature, because static friction is not sufficient to prevent sliding, so kinetic friction will act. Okay, so if you want to visualize, it will be like this. Same thing, mobile phone on book you consider. Okay, you all must have seen examples of these. No, they keep a tablecloth and then glasses or plates on the tablecloth, and then they quickly pull off the tablecloth. The glasses, tables will stay there itself. Okay. So something similar. If I suddenly pull the book aside, okay, fine. Difficult to demonstrate. In slow motion, you'll be able to see better. But you can see the mobile phone is relatively at the middle of the book initially. But if I suddenly push it aside, see what has happened. Okay, the book has moved forward more. Mobile phone has not moved that much. That's why it was here. Okay, so I'll show you slowly what happens. The phone is here, book is here initially. Both move forward, but the phone doesn't move as fast as the book. That is what will happen. Relatively, on the book surface, it appears as if the phone has gone back, but actually both of them have gone forward only. You see, this is the initial position. Okay, I'm pulling the book this way. If I pull the book this way too fast, this is what will happen. This was the phone's position initially. It has moved forward. The book also has moved forward. Book has moved more than the phone. So on the book surface, relatively, the phone appears to go back, but that is not what we are concerned with. So both go forward, but not together.
Sir,
Right? Yes.
sir, is it possible for like the block A to move faster than block B?
While applying force on which block?
B.
అట్లెట్లా అవుతుంది చెప్పు. You are pulling the block B. How can A move faster than B?
సార్ అంటే ఎక్కువ రఫ్ సర్ఫేస్ మీద పెడితే ఫ్రిక్షన్
See,
ఎక్కువ ఉంటుంది.
you are saying will increase the roughness. You increase the roughness to whatever extent you want. Friction at best will prevent sliding. Friction won't cause sliding. No. Now, if you want A to move more than B, situation has to be like this. What can make A go forward? If you are saying you're talking about roughness and also you are saying let us generate a lot of friction and see if A can go faster than B. That is what you are saying, no?
Yes, sir.
But in this case, if at all this happens, it's like friction itself is making A slide on B. Will friction ever do that? Will friction make surfaces slide over each other?
No, sir.
No. Okay. So even if a lot of friction is available, okay, roughness ekku undi, friction ekku available unna kuda, that much friction will not act. How much ever is necessary to prevent sliding, that much only will act. That is why it is important to keep in mind that static friction is a self-adjusting force. The limiting value will not always act. How much is necessary to prevent sliding, that much only will act. So at best, it will make them go together. Otherwise, if its effort is not enough, B can slide faster than A. A will never slide faster than B. Friction will never make one surface slide over another surface. Okay, so that is not possible. Okay, fine. Questions based on this? Like how can we ask questions based on? They can ask you, when a certain amount of force is applied, what will happen? You will have to decide whether they will slide together or not. Okay. They may ask you, what is the maximum force with which you can pull the lower block such that they move together? Okay. What happens if we increase the force beyond that? With what accelerations will they go? They can even give you length of the blocks and ask you when the upper block will fall down from the lower block. Okay. Many questions can be asked. So those are the things we'll discuss in the next class. So today, mostly we solved questions based on kinetic friction, some interesting situations. But see, some of you are still making mistakes taking components of weight and all. You are still writing N is equal to mg. Solve the worksheet. Last worksheet, still none of you has sent the solution. That's why I didn't send another worksheet. Okay. Solve questions from the worksheet, especially those of you for whom this chapter is completed. With half knowledge, there's no point going to the next chapter. Okay, put some extra effort, dedicate some extra time, solve more questions from laws of motion. Right then, thank you all. We'll continue on Friday.
Thank you, sir.